October 21st through the 23rd. Let's go ahead and get started with this do now. How many ways can you represent the fraction 12 over 10? All right, I'll embed a question here for you to type out how many different ways you can represent this. All right, so the first thing I think we can do is we could simplify this fraction. In order to simplify this fraction, we're going to divide the top and the bottom by 2. That's going to give us the fraction 6 over 5. So that's a new way that we can represent this fraction. All right, but there's other ways to represent a fraction. We can complete this division, and that's going to turn this fraction into a decimal. So here I'm going to label these as we go. This is our simplified fraction. All right, 6 divided by 5 is 1.2. So this is a decimal. Another way to represent it would be as a percent. To convert any decimal into a percent, you multiply it by 100%. So 1.2 becomes 120%. All right, and you can come up with even more ways to represent this number. You could plot it on a number line by putting a point between 1 and 2 at about 1.2. So on a number line, and maybe you thought of some other ways. Maybe you made this fraction even more complicated. Instead of simplifying it, you complexified it. Or maybe you added some variables. There's a lot of different ways to represent the same value. All right, but let's move on. Our objective for today is to revisit verbal expressions, practice solving multi-step equations, and look at some common mistakes. Why are we doing this? We're going to have a quiz on multi-step equations next week. All right, so here I've got an equation for you, but it's written out as a verbal expression. The sum of a number and 4 is 14. What is that number? So we have to remember that sum means addition. So maybe I'll write a little plus up here. When we see a number, and I italicized it to hopefully help you realize that this is what we're trying to solve for, we're going to represent that with a variable. So we'll pick x. And when we see that word is, that becomes an equal sign. The 4 is a 4, the 14 is a 14. Let's put this together into an equation. The sum of a number, so x, plus 4 is 14, equals 14. All right, the inverse operation of addition is subtraction, so we'll subtract 4 from both sides, and we get x equals 10, put a box around it, plug it back in to double check. Here's the next one for you. Copy it down. The difference is subtraction of a number, we'll use x again, and 5 is equal sign 15. So x minus 5 equals 15. Inverse operation subtraction here is addition. We undo this minus 5 with a plus 5. Whatever we do to one side, we must do to both sides. And we get x equals 20. Put a box around it. Plug it back in to double check. All right, see if you can get this one on your own. Okay, the product of a number and 7, so x times 7 is 35, equals 35. All right, so we're taking some unknown number and multiplying it by 7. Let's undo that by then immediately dividing it by 7. Whatever we do to one side, we do to the other side. We show our division as a fraction line, and I get x equals 5. And last one of these, the quotient of a number and 4 is 6. So quotient, that means divide. And we want to make sure we do this in the right order. It has to be, since a number comes first before the 4, it's got to be x over 4 equals 6. Undo that, divide by 4 by multiplying both sides by 4. And I get x equals 24. Let's plug it back in. 24 divided by 4 equals 6. 6 equals 6. It works out. All right, question for you. How can fractions appear in equations? Well, here we've got three different examples. They can show up just by themselves as their own term. They can show up with a variable, or one whole side of the equation is a fraction, like we see here. The x plus 5 is on top of that fraction. Copy all three of these down. Let's talk about how to solve these. Okay, when the fraction's by itself, you just move it around like you would move any term. Here it's plus 1/5, so we're going to subtract 1/5 from both sides. Now I've got x equals 6 minus 1/5. We want to turn this into a single number, so we should get a common denominator. Turn this into a 6 over 1, and then multiply it by 5 over 5 to get 30 over 5 minus 1 over 5, which equals 29 over 5, and leave it as an improper fraction like that. Oh, that makes me think, I'm going to go way back to that first slide. We never turned this into a mixed number. So this is a simplified fraction. It's also an improper fraction. You can turn it into the mixed number 1 and 1/5 here. Okay, good. I knew there was one more. All right, but I like improper fractions for answers to equations, so we'll just leave it like that. All right, with a variable. Here we want to save that fraction for last, so let's move the 3 first. And we get x over 4 equals 9. Now you can get rid of that over 4 by multiplying both sides by 4. And I get x equals 36. All right, and then the last one where the whole side is a fraction, then you get rid of that fraction first thing. The entire side is being divided by 2, so let's multiply the whole side by 2, and it'll get rid of that divide by 2. Whatever we do to one side, we do to the other. Now I'm left with x plus 5 equals 22. Subtract 5 from both sides, and I get x equals 17. Put a box around it. All right, I have one multi-step equation for us to solve here. Go ahead, copy it down. All right, we got to go through all of our steps here. The very first thing we look for are parentheses that we can get rid of. And I've got parentheses on both sides, and I get rid of them either by turning the inside into a single term and dropping it, but if I don't have like terms, I have to distribute. So show distribution with those rainbow arrows. Now we get 8b minus 2 equals negative 14 plus 14b. The next thing we look for are like terms, but specifically like terms that are on the same side. We don't have that here. So the next thing I look for after that is variables on both sides. I always want to move the smaller one. So I've got 8b and a 14b. I'll move that 8b by subtracting 8b from both sides. Negative 2 equals negative 14 plus 6b. Next thing I look for are constants on both sides, and I always want to move them away from the variable. So let's add 14 to both sides. And I get 12 equals 6b. Divide both sides by 6. Is the last thing I'm looking for is coefficients that I want to divide away. And I get 2 equals b. Flip that around. b equals 2. All right, so I'll put more multi-step equations in for you to practice at the end of this. Let's look at some common mistakes. Can you spot the mistake here? All right, so the mistake is right at the top here. All right, we subtracted m, but we didn't subtract it from both sides. We actually subtracted it twice on the same side. When you have like terms, we should have combined these like terms. So we should have combined the like terms. Okay, go ahead and solve it now. Next one, where's the mistake here? So right here, we've got negative 6p, but we added p to get rid of that, or we added 6 to get rid of that negative 6. This is negative 6 times p. There's invisible multiplication there. We should have divided away by negative 6. So we should divide both sides by negative 6. That's how we get rid of that negative 6, because we ask ourselves, what is it doing to the variable, and then we undo that. Next one. All right, so the mistake here is right here. We have negative 2m, but we only divided by 2. That doesn't get rid of the negative, so this should be a negative 2. Okay, finish solving this one. And last one, where is the mistake here? All right, the mistake is right here. When we divided these two terms by negative 2, we're going out of order because we should have moved the constant first. But what makes this a mistake is that this is in itself is not sufficient to get the wrong answer, but if you're going to divide, you have to divide every single term by negative 2. So we should have moved the negative 2 first. Or we could just make sure to divide every single term by negative 2 and you'd still get the right answer. All right, go ahead and finish solving this one. All right, I'm going to embed a few more questions here for you, but that's that for this lecture video. Have a good rest of your day.